Hi, this is Ben and Mac, and this is Optimizing Lineups for Daily Fantasy Sports.
Our project revolves around the daily fantasy sports industry, where people all over the country handpick lineups of actual professional athletes across various sports and win real money based on those players' statistical performances in real games. The two largest players in the industry, FanDuel and DraftKings, have raised more than $400 and $600 million in funding, respectively. There are millions of active users, and millions of dollars are awarded every week in weekly contests. While users can choose various sports, as big fans of the NFL, we chose to do it around football. We're going to use machine learning and analytics to predict and optimize the best possible lineup for a chance to win real money.
So why football? As Mac mentioned, him and I both grew up as lifelong football fans, and we chose to analyze the sport even further. There are 32 teams in the National Football League. Each team plays 16 regular season games, with 4 playoff games for the top performing team yielding one champion, which is the Super Bowl champion. There are 11 players from each team on the field at a time, 11 players on offense and 11 players on defense or special teams. In daily fantasy sports, the defense counts as one player since they all have one objective: stop the offense so their team's offense can get the ball back for a chance to score. The defense can also intercept the football and score, therefore gaining points. That is why they are also a player. Daily fantasy sports focuses on the scoring player positions, which are defense, quarterback, running back, wide receiver, tight end, and kicker. With so many teams and players, there are so many other variables like weather, injuries, legal battles between players, and contracts between teams. So there are trillions of possible outcomes for any group of players to score points. There are so many variables, which makes it a perfect application for data mining and machine learning.
So how does it work? So every week before the contest, you pick your lineup. This is typically one player from each of the positions that Ben mentioned, so quarterback, wide receiver, running back, tight end, defense, and kicker, and sometimes a flex player, which can be one of those. Every player has an associated salary or cost, and your whole lineup has to stay below some certain threshold, say $50,000. When the games actually start, players are awarded points based on their performance in the actual game. Catches, touchdowns, rushing yards all result in a very specific amount of points. For example, rushing a touchdown gives you 6 points. After all the games have finished and your players are done playing, lineups in the top 25% of all the lineups entered into that contest win cash prizes. Sometimes the top players can win hundreds of thousands of dollars. We chose to work with DraftKings because it's one of the biggest competitors in the industry. Some of the other ones are FanDuel and Yahoo, but DraftKings is the biggest out there, and it's also based in Boston. The company has over 500 employees, it's growing really fast, and was recently valued at over $2 billion. Some interesting facts about DraftKings: there are 10 plus million active users on the app. They've raised over $600 million in venture funding to date. 80% of the winnings every week go to the top 5% of players. As Ben mentioned, this is a perfect application for some machine learning and data analysis.
So our project objective for daily fantasy sports has many different weekly competitions to choose from. We chose to work with a competition where the user picks 6 individual players from varying teams to score the most points. Simple, right? Wrong. Each player has a salary given to them, which we can see over here, their player name, their position, and their total projected points to score that week. This is a points value given by statisticians from the NFL and in Las Vegas to give betting lines for different people in competitions. And this varies from week to week because a player may score more or fewer points than they were projected. So the overall goal is to pick undervalued players to outscore their projected points and get them for a lower salary. That way we can have the optimal combination while still remaining within our salary cap. So how do we do this? Algorithms. To achieve the optimal lineup, as I mentioned, we have a salary cap, let's say $50,000, and we cannot exceed that salary cap. So there are many possible approaches for this problem. We're going to take a look at a bunch of different models and compare the outputs and see how they can work together. linear programming problem approach, greedy algorithms such as knapsack, random forest regressor, neural network, ridge regression, lasso regression, elastic net regression, and gradient boosting regression. So, we'll start with the simplest, the linear programming problem. We've all taken a math class where we've seen this, but just to reiterate, it consists of an objective function, decision variables or features, constraints or restrictions, and one unique attribute is that the non-negativity restriction applies. This is great for football because players don't score negative points, their points totals are always increasing. A simple example of the linear problem is seen below that we've all seen from math classes. Next, we have our greedy algorithms. One of the most classic and widely used greedy algorithm approaches is the knapsack. So many of you have probably heard of this, but just to explain it further, the knapsack algorithm is designed around a simple tale. A robber is going to rob a house. He has a knapsack of a certain size. The knapsack can only hold a certain amount of items. However, the house has many items of different weights and values. So the robber must choose the optimal combination of items given their value to fit in his knapsack to get the best possible outcome. We call this the global maximum. So, for these two approaches, we used a single week of data to solve the respective problems. For this instance, we used one of the most recent weeks in the NFL, Week 12, from the DraftKings dataset. This is downloaded from an affiliate website. So we can see we have the player names, their position, this is just quarterbacks, for example, varying salaries, and varying points. So, as we can see from running the linear problem solution and two different iterations of knapsack, one trying to be a little simpler than the other, we have many different errors. The linear problem resulted in an error of 2.66%. This is incredibly good. However, this picked Michael Thomas as a wide receiver for the flex position when we already had him for a wide receiver. Some competitions may allow this, while others might not. So this might not be the best possible prediction. For our first knapsack solution, we have different outcomes. Michael Thomas is also selected as a wide receiver. However, Alvin Kamara is now our flex at running back. And even though we have a lower points total and a worse error of 6.14%, this may be a more realistic prediction. Now, with our second approach at the knapsack algorithm, we try to simplify things a little bit to make it run faster, and we also got a different result. So here, we can see we also have Michael Thomas as wide receiver, Lamar Jackson, Cleveland Browns, Christian McCaffrey, Zach Ertz. However, we got Julio Jones as a flex. So this has an even lower points total and a worse error. So what we can draw from this is that although all of these algorithms predicted different results, they may differ week to week, and some of these flex players may actually outperform the other from week to week. However, we don't know factors in these algorithms such as weather, if they're having family issues. So these are all things that statisticians, psychologists take into account when looking at these. And these are some things that we tried to analyze a little bit further with machine learning.
So with the machine learning approach, as Ben mentioned, we implemented a couple different algorithms. We also had to use a little bit of a different data set since we had to train the models as well. So we ended up using about 2.5 years of NFL data scraped from the NFL's actual live API. Just talk quickly about a few of them. Ridge regression and lasso regression, which we learned about in class. Both have a penalty on the model. Ridge regression uses L2. The idea is to shrink the coefficients. We'll trade variance away for a slight increase in bias. However, it won't eliminate coefficients that are relevant to the data, unlike lasso regression, which will. Lasso regression tends to be more useful in situations where there are a small number of meaningful parameters, which might make sense here. We also use random forest and gradient boosting. Both are based off decision trees. Random forest will build hundreds or thousands of trees. It'll utilize feature selection, and each tree is trained on a random segment of the training data. At the end of the algorithm, the idea is that the overall forest of trees will have lower variance without increasing the bias. Gradient boosting is a little bit different. It'll build a new decision tree every time, one at a time, off of the prior tree, reducing the loss function each time. Results. So looking at the mean absolute error, mean squared error, RMSE, and the R-squared score, we can see that overall the algorithms are pretty successful, but some are a lot better than others. You can easily see that gradient boosting was the worst performing algorithm. Its R-squared score was about 75%, whereas some of the other algorithms were up at 98 or 99%. Overall, we think it was really successful, but you can see that some were better than others. While also going through this, we learned a lot about the data outside of the algorithms. As lifelong football fans, there are things that we always thought, such as players playing at home versus away, weather conditions, things like that might impact a player performance. As you can see in the bottom left, there really is no difference between players who play at home versus players playing away. In the top right, you can see the density plot of points scored by position. You can see that the quarterback position in blue is more spread out, whereas something like a tight end in the red is more close, meaning the tight end on every team is going to score somewhere around the same points every week. Future work. There was a lot that we didn't get to consider in this, and we took out a lot of the more advanced statistics that a lot of the people in Las Vegas and the NFL will use, statisticians, as Ben mentioned. In the future, there are a lot of things we want to do. First off, it'd be great to weight by matchups to identify hidden opportunities. On the heat map on the right, you can see how certain positions will score more or less points against certain teams. So the idea would be that you'd want to play players against a bad defense every week rather than someone who's playing the best defense in the league. Other ideas would be to use, again, like I mentioned, the advanced statistics that we originally took out. It would also be helpful to gather data on the rates of players that are chosen for DraftKings lineups. If every lineup picks the same players, then you didn't outperform any of them, so we would have to identify hidden players. Other things would be momentum analysis. Some players go on hot streaks where they have a couple of good games in a row. But generally, the idea is that we would refine the model over time given our real-time results.
Thank you.